Hi students, now we see about semiconductors, the topic transistor and triode, and some formulas and problems related to it. The class notes PDF link is in the description, so go through it for better understanding. So the main difference between transistor and the triodes is the transistors are current controlled devices, triodes are voltage controlled devices. So the formulas are moreover similar. There is the only one formula is transconductance. The formula it is asked in IIMS, JIPMER and many exams, but many books lack it. So we are going to see some details about it. So transistors are current controlled device. We have three regions. It is a solid state device. We have three regions, that is base, emitter and collector. We know that CB mode, CE mode, you know, the common base mode means base is grounded, the common emitter mode is emitter is grounded. It is an Npn transistor, so the arrow mark is this like. So the input signal is given to the base and the output is in the derived from the collector region. So this is a positive and this is negative. Whereas in triodes there are three components, like this is a cathode, this is anode, that is anode plate, cathode, then this is the input, the control grid. So we will see about this as in the detailed diagram. So here we see the NPN transistor and it is the triode. So for NPN transistor, this is the base resistance, that is input resistance, input voltage, input current, this is the base, the emitter is grounded, this is the emitter current, then collector current, the load resistance. Here we derive the output, this is the output potential, this is the collector. So this is the diagram, detailed diagram for NPN transistor. So here the input is given to the base and output is derived from the load resistance in the collector. So in the triode, so there are three components: control grid, cathode and anode. The anode resembles the collector, control grid resembles the base and the emitter resembles as cathode. So the cathode is negative, so the electrons are repelled or emitted from the cathode goes to the anode, so because it is the positive potential. This is controlled by control grid. So basically the control grid is attenuating the current, that is if many electrons are emitted from the cathode, they are going to tend to go to anode, but the control grid controls it through the small input voltage, there is small input signal given to the control grid. So if a negative signal is given to the control grid, it repels all the electrons and they don't tend to go to the anode. But if the positive potential is given to the control grid, the electrons are tend to fly through the control grid and reach the anode. So in the anode we can get the output, that is the V output, that is V output, that is V output is nothing but V plate. So plate potential or anode potential is the V output. So the output is derived from the anode and the input is derived from the control grid. So control grid is the input, output is the anode plate. So are we clear? So are we clear about NPN transistor and triode? So next we see some formulas related to the transistor. So transistor, it is the CB mode, the common base mode. Here the base is grounded. In common emitter mode, the emitter is grounded. So current gain in common emitter mode, common base mode is alpha, that is IC by IE. In current gain in common emitter mode is beta, that is IC by IB. Because the emitter is grounded, so IE current is not taken. So voltage gain AV is equal to output by input. So any gain is output by input. So output is V output by V input, V equal to IR. So IC, RL, RL is RC. They are the output. The output is delivered in the collector. So we denote the IC, that is collector current, and load voltage. Input is here emitter region. So R input, I input. So VI equal to IRE. Here voltage gain is equal to V output V input. Here the output is collector the same and the input is through base. So IB into RA. Okay, so AV, the voltage gain can be related as alpha into RL by RI. So alpha is nothing but IC by IE. For CV mode it is alpha, for CE mode it is beta. So that's all. You have to memorize these formulas because it will be helpful in easy problem working conditions. Like for power gain, so power gain for CB mode, AP is equal to P naught by PI, P output by P input. P output is nothing but VI. So here in the CE mode, the same power gain is equal to P output P input, P output equal to V output I output divided by PI equal to VI II. So current gain in CB mode is written as alpha square, that is RL by alpha square into RL by RA. In CE mode it is written as AP, so this current gain is equal to beta square RL by RA. So phase difference between output and input. So many questions are asking, like many people, many exams, what is the phase difference? That is the phase difference between the output and input. It varies in CB mode and CE mode. In CB mode, that is common base mode, the phase difference is same phase, in phase, that is the 0 degree phase difference. Here it is opposite phase, out of phase of 180 degree. So the transconductance, this is the most important topic. Many will miss, like this is the most important and it will be asked in many exams. So the transconductance is nothing but the ratio of change in current at the output terminal to the change in current, to the change in voltage at input terminal, that is current in the output divided by voltage in the input, I output by V input of an active device. So for GM this is the denotation for transconductance. For triode it is I naught by Vg. Vg is the input potential. Here Vi are base potential. Vi or Vb we can take according to the CB or CE mode. So for transistor this is the formula. For triode this is the formula. So next we see a few problems about this is transconductance and the transistor. So the first problem is the current in a triode at anode potential 100 volt and grid potential minus 1.2 volt is 7.5 milliampere. If grid potential is changed to minus 2.2 volt, the current becomes 5.5 milliampere. The value of transconductance Gm will be. So we have to calculate the transconductance value, and the given data is anode potential is output potential, grid potential is input potential, and the current the only one and only current. So the input potential, that is grid potential, changes from minus 1.2 volt to minus 2.2 volt. The output current, that is anode or plate, changes from 7.5 milliampere to 5.5 milliampere. So we know the given data, so we have to calculate the transconductance. We know the transconductance formula. Gm is equal to output current by input potential, provided output voltage or potential is constant. So Gm equal to I naught by Vg. So here is the difference in I naught and difference in Vg. So we have to calculate the difference. Difference means output minus input. So 7.5 minus 5.5, because the current changes from 7.5 milliampere to 5.5 milliampere. Thus this is the output and this is the input. So 7.5 minus 5.5 whole milliampere, then minus 1.2 minus of minus 2.2. This is the final and this is initial. Okay, on simplification we get transconductance Gm is equal to 2 millimho, that is ohm inverse. So this is the transconductance. On simplification we can get this from 2 value. So this is one of the problem in transconductance. Please remember this formula is very important. Many questions many exams they will ask transconductance. In many books they left it, so please note this formula. The next question is the input resistance of a common emitter transistor amplifier. If the output resistance is 500 kilo ohm, the current gain is alpha, that is 0.98, and the power gain is 6.0625 into the power of 6. So they are asking the input resistance of a common emitter transistor amplifier. So we have to calculate the input resistance of common emitter transistor. For common emitter transistor, the current gain is beta. So alpha, they are given alpha. So alpha is common base. The current gain for common base is alpha. So power gain, they given power gain and output resistance. So the given data is output resistance 500 kilo ohm, power gain 6.0625 into the power of 6, and current gain, that is alpha. This alpha is for CB mode, common base mode. Alpha is equal to IC by IE equal to 0.98. So we have to calculate first beta, that is current gain for common emitter mode. Then we have to calculate the input resistance. So for input resistance we can calculate through power gain. We know the power gain formula and we know the current gain formula also. For current gain for CE mode, beta is equal to alpha by 1 minus alpha. This is the relation between beta and alpha. This is derived from there is a 3 layer emitter, base and collector. in the transistor. So the electrons are emitted from the emitter, and it's going to and deposit in the collector. So when 100% of electrons are emitted from the emitter means 5% goes into base and 95% goes into collector. So the collector current IE is equal to IB plus IC. So IB, from that derivation we derived beta equal to alpha by 1 minus alpha. This is the final equation. So alpha is equal to 0.98. On substitution 1 minus 0.98. On simplification we get 49, that is beta equal to 49. So power gain, we know the power gain formula equal to beta square R naught by Ri, output resistance by input resistance we know. Then on substituting for power gain 6.0625 into the power of 6 equal to beta square, so that is 49 into 49. R naught, that output resistance is 500 kilo ohm, that is kilo means 10 power 3 whole divided by input resistance Ri. We have to calculate Ri. On reshuffling and simplification we get Ra, that is input resistance Ra is equal to 198 ohm. So this is the answer. So these are the two questions. For transconductance you should know the formula, and so the class notes PDF is in the link given in the description, so go through it.